This video will cover a solution guide to problem 72 from chapter 2. An entertainer juggles balls while doing other activities. In one act, she throws a ball vertically upward, and while it is in the air, she runs to and from a table 5.5 meters away at an average speed of 3 meters per second, returning just in time to catch the falling ball. With what minimal initial speed must she throw the ball upward to accomplish this feat? How high above its initial position is the ball just as she reaches the table? In order to determine the initial speed the ball needs to be thrown in the air, we first need to know how long the ball has to stay up there for the juggler to be able to catch it when she returns to her initial position. The juggler runs to a table 5.5 meters away and then runs back to catch the ball. This means that she runs twice the distance to the table during this performance. The statement tells us that she does this with an average speed of 3 meters per second. The distance traveled by an object is equal to the speed multiplied by the time. If we rearrange this equation for the time it takes her to run to and from the table, we will know how long the ball is required to stay above its initial launch point. Plugging in the numbers, we see that the ball must stay in the air for 11/3 seconds. The ball's motion is subject to the constant acceleration due to gravity, so we can use one of our constant acceleration formulas in order to obtain the necessary initial speed of the ball. We can use the formula, the total displacement is equal to the initial velocity times time plus 1/2 at squared. Because we're finding the minimal initial speed, the ball's initial position is equal to its final position, making delta y equal to 0. We can factor out a value of t and ignore it since we are not interested in the t equals 0 case. We are evaluating a situation after the ball has been thrown. Solving our equation for the initial velocity, we see that it's equal to 1/2 g times t. Subbing in the values given, the initial velocity of the ball would have to be 17.9 meters per second in order for the juggler to make it back in time to catch it. To find the height of the ball above its initial release point when the juggler reaches the table, we can use the exact equation as before, but with slight variable changes. When the juggler reaches the table, the ball will be at its maximum height, causing delta y to no longer be 0. Instead, it's the variable we want to solve for. The ball will reach its maximum height halfway through the performance. In other words, we will use the time we solve for in part A divided by 2. Subbing in the values given and the initial velocity and time we solved for in part A, we find that the ball will reach a height of 16.5 meters above its original position when the juggler reaches the table.